Hello everyone, so today we are solving this problem. Find closest node to given two nodes. Okay, so you are given a directed graph of n nodes, 0 to n minus 1, where each node has at most one outgoing edge. Okay, there could be only up to one outgoing edge, not more than that. So the graph is represented by zero index array edges. Okay, so edges are in such a way you can visualize here. For example, this is our graph. Let's say node 1 is 0 and node 2 is 4. Okay, so how the edge will look, for example, from 0 to 5 there is edge, right? So there we would mention 5 like this. Okay, now come to 1 don't have any outgoing edge, so it would be having -1. Okay, now come to node 2 has outgoing edge to 1, right? So we will write here 1. So edges are interpreted in this way. Now 3 is connected to 2, so we are writing here 2. 4, so 4 is connected to 7, so we will write it here 7. 5 is connected to 6, so we will write it 6. 6 is connected to 2, so let's write here 2. Okay, and similarly 7 is connected to only 6, so we will write down it 6. So all the index are connected. The value at that index is actually the number of, the node number where it is directly connected to. For example, 1 is not connected to any node, any outgoing node is not there, that is why we have put -1. So what we have to do is basically two nodes are given to us. Let's say 0 and 4 in this case. This is 0th node, this is 4th node. So what we have to do, we have to find the such nodes which are reachable from both of them, node 1 and node 2. So there could be multiple nodes which are reachable, and in those reachables we have to find the distances and the maximum, which one is the distance, and out of all those maximum which one is minimum. So let's do a dry run, then we will understand in a better way. So for example, from 0 5 is reachable, but from 4 it is not reachable. So from 0 6 is reachable, right? So what is the distance from 0? So from 0 till 6 is reachable, so the distance is 1 and 2 is the distance, right? There are two edges, so 2. Now similarly from 4 to 6, how many? So from 4 to 6 is also 2 nodes, right? So we will take the maximum of these two. So 2 on 2, what is the maximum? Maximum is 2 only. Okay, we found 1. Now see who all are reachable. 2 is also reachable from both of them. Okay, so what is the distance here for 2? For node 2, you can see here, this is 1 2 3, and similarly from 4 also 1 2 3. So what would be the max? The maximum of 3 and 3 is 3 only, right? So we will write it down 3 here. Now see who all are reachable. 1 is also reachable from both of them, right? So 4, it is at a 4 distance from 0, and similarly 1 2 3 4 distance from 4. So 4 and 4 is another node. The node 1 is also at a distance of 4 and 4. So what is the maximum? Maximum is 4. So basically we have found the distance, maximum distance from both these 4 and 0. Now out of these maximum, which one is the minimum value? Minimum value is 2. So this 2 came from which node? This came from 6 node. So our answer would be whoever is the minimum, 2 is the minimum distance, that came from node number 6. So node 6 should be our answer. So this is what we have to do. Okay, now next thing is how to do that. So to do that, we will do simple thing. What we will do is, first of all, from node 1 we will get the distance of all other nodes. Similarly from node 2 also we will get the distance of rest of all other nodes. Once we would have the array of distances for node 1 and node 2, we would be interpret those two arrays, and we will find this thing what we have done. Simply for loop we can use, and that we can do, right? So let's do that as well. So if we make the distance array, how would it look like? So from 0 we can easily find, right? We can write a BFS or DFS, any one of them. So I have written BFS, so let me tell you how I have done it. So this is my code. So see here, I have written this method, count distance from any node, let's say start node, and the edges are the edges given for that question, right? So see here, what I'm doing initially, I'm getting the length of edge because this would be give us the number of nodes. Then I'm creating a distance array of size n because we need to find the distance from this start node to all other, right? So initially I'm filling the distance equal to max value. Why I'm filling max value? Because this is a directed graph and there's a possibility that there is no path for some of the nodes, so that should be unreachable. For that reason I'm doing. So initially from the start itself the distance would be 0, right? And I have created one boolean variable to keep track of those visited node. Now what we are doing in a BFS way. So I have created a queue here and we have pushed the start node initially. Now see here, we are till the time when queue is not empty, we are popping them out. So I have popped out the node. Now we are checking that, hey, is it already visited? If it is already visited, we don't have to count it again. Then we are making it continue. Otherwise, if it is not visited, let's make first it visited. And then we are, from the edge, we will get that who is the next node which is connected to it, right? As per this edge, right? For example, if we are at 0, then next node would be 5. So from this edge array, we can easily get that, right? So for that reason, I am doing this part. Now we are doing one thing here, that if the next node should not be -1, because otherwise that will not be reachable. For example, here if we are at node 1, there is no node next it is connected to. That is why -1 check is put there. So, and if it is not already visited, then what we are doing, we are putting the distance of it. So distance of currently next node would be the whatever is the 1 plus whatever the distance of node that be popped out, right? Because the distance would be increased by 1 to the connected node. And then we are again pushing the next node as well. So similar way, when we will be completed, we will find the distance of all the nodes from this start node. So this utility method we are using to find the distance of our given node 1 and node 4, right? We are given 2 nodes, right? So we will get the distance array using this BFS method, and then we are using this. So see here, I created 2 distance variables, the array distance 1 and distance 2 for the node 1 and node 2. Okay, so see here, I have created one variable called minimum distance and answer node. We will use it later. So now see here, what I have done is, first of all, I have got the distances from this node 1 and node 2. So these 2 array would have the distances. It would be look like if we do the distances here. So for both node, the distances would be like 0. So from 0 to 0 distance is 0, 0 to 2 distance is 4, 0 to 3 distance is infinite, right? It is not possible. 0 to 4, that is also infinite, not possible, no path is there. Now 0 to 5 distance is 1, we have written. 0 to 6 distance is 2, and 0 to 7 infinite, because that is there is no path. Similarly from 4 to 0 infinite, right? 4 to 2 we have distance at 4, 4 to 3 it is distance 4 to 2 it is distance as 3, and 4 to 1 it is distance as 4. So all those distances we have got using this BFS method. Okay, now what we will do is, we have to look for all these distances, and then we have to find where could be the best possible node, right? The maximum of the minimum. Okay, minimum of all those maximum, sorry. So see here what is happening. If we look now in these 2 loops, so see here, these are reachable values 4 and 4, right? But this is value 4. Okay, now this also reachable, but the max value here is 3, right? These are infinite, not reachable, not reachable, not reachable. This also reachable because 2 at 2, these are the distance reachable. So maximum is 2. Now this is not reachable. So out of these 3 values, whatever is the minimum coming from, right? 2 is the minimum, which is coming from node number 6. This is 6th value, right? So 6 would be our answer. Okay, so this is what we are doing here. So let's continue with my code part. So with this count, what we are doing is, see here, we got the distances from the node 1 and node 2 to all. Now we have created this min distance variable and the answer node initially -1. Now what we are doing is we are using this for loop and finding for all the reachable values, we are getting the max value. Okay, so if this max value is lesser than the min distance, we are assigning that value maxwell and answer node equal to that I. Now we are checking further. So whoever is the giving us the minimum value, with this check we will find, just like we were doing here. So we are returning. So let me execute this code, which I have already executed, but for the sake of this video we are executing again, and the time complexity is in order of n only. We are not doing any 2-time traversal kind of thing. So yeah, so thank you for watching this video, and if you guys have any concern, please make a comment over there.